We have a question from 6.5. The sampling distribution of the sample mean. Random variable X is not normally distributed. It has a mean of 46, standard deviation of 4. So mu is 46. Mu is the population mean. And sigma is 4. Population, standard deviation. If you take a sample of size 24, so now things get interesting. N equals 24. Can you say what the shape of the sampling distribution for the sample mean is? So that's a formula already used in this little segment that you have to know and really memorize. The sampling distribution of the sample mean. Okay. So the X variable looks like this, but sample size 24. Now, if it were 30, then we would just say normal. But because it's less than 30, we're saying no, we don't know the shape of the sampling distribution of the sample mean. Why or why not? Check all that apply. Population is not normal. That is critically important. And it says that, yeah, not normally distributed. N is at least 30, which is not even true. Population is normal. That's not true. N is less than 30. Yes. And sigma is known, but I don't think that matters. Sigma's being known or not known matters. But not here. For sample size 24, state the mean and standard deviation of the sampling distribution of the sample mean. Okay, well, the mean of the sampling distribution of the sample mean, that's going to hang right there at 24. Or at 46, I believe it was. But the standard deviation of the sampling distribution of the sample mean is going to be not that, I think it was 6. Not 6. Oh, 4, not 4. But it'll be sigma divided by root n. Sigma divided by the square root of n. because we're talking about the sampling distribution of the sample mean. A big important thing that we're talking about. So by the central limit theorem, sigma over root n, which is 4 over the square root of 24, which is this number, which is approximately 0.82. You take a sample of size 45, can you say that the shape of the distribution of the sample mean is? Yes, in that case, it's going to be normal. And why or why not? Population is still not normal, but that's not a reason why we're going to say that the sampling distribution of the sample mean is now normal. So n is now 45. Now we're going to get this nice bell-shaped curve for the sampling distribution of the sample mean. What's the sample mean? X bar. So this is a distribution not of x's, but of x bars. The mean of that distribution will still be 46 because the mu of the x bars is the same thing as the mu of the x's. But of course, according to the central limit theorem, the sigma of the x bars is the sigma of the x's divided by square root of the sample size. Let's see. And so if n is now 45, we couldn't say it's less than 30. It's at least 30. Population is normal, no. Sigma is known, yes. And some would argue that that is part of the reason why we can say the shape of the normal distribution or the sampling distribution of the sample mean is normal. Let's see if they can say that. Sigma is known. Okay, so not only can it be argued that way, but this question writer, evidently following Kozak, says yes. For sample size 45, state the mean and standard deviation of the sampling distribution of the sample mean. The mean, well, we know that's going to be 45 because of this. Or I'm sorry, the same is 46. 46, the same as the mean of the population, the same as that thing. But the standard deviation, according to the central limit theorem, okay, so in 6.5, you'll see a statement of the CLT. Also in the ALA, the CLT with one die, it has the, well, these two important equations are, you know, the heart of the central limit theorem. As I remarked in the ALA, the CLT with one die, the statement Kozak has in section 6.5 of the CLT is weird. It really should include these two equations as it does in the definition linked in that ALA. So sigma divided by root n, 4 divided by square root of 45. Second enters entry, edit the expression there, call it 45. So there's our new standard deviation of the sampling distribution of the sample mean. 0.5963 to 2 decimal places, 0.60. 0.60. Learn by doing. Eventually, mastery matters. Hope you found this helpful.